We are doing exercise 7D, and in this video I'm going to be answering question 1A which says, for each of the following, find a sequence of transformations that takes the graph of y equals x squared to the graph of y equals 2x plus 1 squared minus 2. Alright, so we know that we're starting with a point xy, and we are then applying a transformation. But we do not yet know what that transformation is going to be. That's what the question is asking. We're trying to figure out what they're going to be. So we're just going to say it's x dash y dash. So that's going to be my newly transformed point. So I'm starting with one point, applying a transformation, and I'm arriving here. And what I'm trying to do is figure out what this x dash and y dash is, because that will tell me what my sequence of transformations are. I also know that this x, y spot is going to lie on the graph y equals x squared. It's going to lie here. A transformation is then going to be applied to this graph, and I'm going to get this. Y equals 2x plus 1 squared minus 2. Now, just as xy lies on this graph, well, my newly transformed point is going to lie on my transformed graph. So I can put x dash and y dash into this, and that's going to be my first step. My first step is simply going to be putting x dash and y dash into this graph here. Let's now move on to my second step. My second step is going to be all about rearranging. So let me just copy this down the same. This isn't going to change, obviously. So now I'm going to get this negative 2 on the other side. So I'm going to plus 2 to both sides. So I'm going to get y dash plus 2 equals 2x plus 1 squared. Perfect, that's step 2. Let's now go to step 3. In step 3, I'm going to say let y equal this and let x equal this. So I'm saying let y equal this, y dash plus 2, and let x equal this. Whoops. Make sure you carry down those dashes. I forgot that there. It's very important that you don't forget. 2x dash plus 1. Now, as I said at the very beginning, the aim of the game is trying to figure out what my x dash and y dash are. Well, to figure that out, since I have these now, I just need to rearrange them to get y dash as my subject and x dash as my subject. So that's going to be step 4, some more rearranging. So I'm going to minus 2 to both sides. And here I'm going to, all right, so this is where it gets a bit tricky. I'm going to minus 1 to both sides, then divide by 2. And I get that. Perfect. So as you can see here, I figured out what my x dash equals. It equals x minus 1 over 2. So up here, I can say, in this spot, I can put x minus 1 over 2, and in this spot, I could put y minus 2. So let me come here, and let me write it in two different, let me just write it down normally first. Let me not get ahead of myself. So I have x minus 1 over 2, and in my y dash spot, I have y minus 2. Okay, now, I'm going to grab this, and I'm going to put this over here. Let me come down a bit. I also want us to appreciate the fact that this could be written differently. So let me actually grab it again. Let me make a copy of it and bring it over here. I could write this differently. I don't have to write x minus 1 over 2. If I wanted to, I could write it like this. I could say x over 2 minus 1 over 2. Both of these ways is an acceptable way to write it. And the reason why I'm bringing this up is because it's going to impact how we're going to write down our sequences of transformations. Here, if we're looking at this, the very first thing to happen to my x is I'm timesing it by a half. So this means I'm doing a dilation by a factor of a half from my y-axis, and then I'm doing a translation of a half from my x-axis. And that's exactly what we see in the answer right here. So as you can see here, I have this 2 divided by 2 here. So I have a dilation of a factor of a half from the y-axis, And then I have this minus 2, which is then a translation of a half a unit in the negative direction of the x-axis. And of course I have this negative 2 here at the end, which we all know. But I could actually write down my sequences of transformations differently. So let's come over here now. Oops. I could write it down. Let me grab this pen. Actually, let me grab this one. I could write down my translation first. So I could say I have my x, and the very first thing that I'm going to do to it is a translation of 1 unit in the negative direction of the x-axis. And then I'm just going to do my other translation as well. I'll just do all my translations at once, and then 2 units in the negative direction of my y-axis. So after I've done my translation here, after I've done that, then I'm going to divide my result by 2. So then a dilation of a factor of a half from the y-axis. So I want you to take note that there are 2 different ways I can write down my sequences of transformations. The textbook, for the most part, always puts dilations first. And it's probably a good habit for you to get into, is when you're writing down sequences of transformations, always write it such that you can write a dilation first and then your translations. But I want you to know that you could write it differently. And let me just prove to you this one more time. Let me come here, grab a pen. Okay, so I'm going to prove it to you. So let me first do it this way. So here is a point. I have 0.44, so this is just a random point. And I'm first going to do a dilation of a factor of a half from the y-axis. So I've got my point, and if I'm dilating by a factor of a half from the y-axis, that means I'm going to be taking my x value and timesing it by a half. 4 times a half is 2, so it's going to be moving there, which makes sense. It's dilating by a half. Now, then I'm going to do a translation of half in the negative x direction. So that means I'm going to take it and move it a half. So a half would be there. So as you can see, I'm at 1.5. So that's one way to do it. Let's now do it this way. So this way is telling me I'm first going to move it negative. I'm going to move it 1 unit in the negative x direction. So I'm going to take my 4 and move it 1 unit in the negative x direction. And then this 2 here, let me highlight that 2. This 2 here is telling me I'm going to divide it by 2. So a dilation of a factor of a half from the y-axis. So I'm going to take my value, and my x value is 3, and I'm going to times it by a half. 3 times a half is 1.5, which is going to bring me there. So as you can see, I get to the same spot. Whichever way I use, I get to the same spot. So that's me trying to prove to you that it really doesn't matter which way you do it, but it is a good habit to get into to put your dilation first. Hopefully that was helpful and brings some clarity to this question. I imagine some of you might have some trouble with it. If you're still having trouble with it, come speak to me so we can iron out any difficulties. But I hope this was helpful in answering 1A III.